Okay, so we have another equation. As you can see, solve for k. Going to have k to the 1/2 times this expression here, 1/2 r over 1/2 r over w times k, all to the 1/4 equals q, and we're solving for k. Alrighty, rewriting it over here. I'll try and keep it kind of consistent in terms of keeping it between the lines. It just keeps it neater to a degree. There's a bit of diminishing returns on that. And yes, it can start out pretty well, but it will end up looking quite condensed. And when there's a lot of things happening, it might not be the most advantageous thing to do. Equals q. Okay. So, first things first. We are wanting to isolate k. We have k in two terms, and one is being multiplied through this term, and one is within this bracket, all raised to the 1/4 power. Now, because this k is being multiplied through that, and I want to isolate k by itself, I want to isolate it, I'm going to divide this expression. And I am going to divide it by k, because that will cancel. And there's an equality sign, so L has to equal R. By that, I mean the left-hand side has to equal the right-hand side. So whatever you do to one side, you must do to the other. To keep them equal because of the equality sign. So I will have to divide this through by k to the 1/2. Keep that exponent there. That comes along for the ride. But we're going to rewrite this term. We will have 1 over 2 r over w k, all to the 1/4 equals q. And going back to the rule of fractions and exponents, you have a over b to the c. That will equal a to the b. When you move that up to the top, that exponent will produce a negative. I should mention a 1 is replaced. So if you have a squared, that is going to equal, and you want to move it down to the bottom, and you just have a squared by itself, you will end up with 1 over a to the negative 2. But because we have a variable on the top, 1 times anything is just itself. So you don't really need to represent the 1 in this case. But that will give us, moving that up top, okay, it's a multiple, so negative 1 over 2. And now you have k not being multiplied through by itself. You have it on the right hand side, and the left hand side. And now what do we do after that? Well, first I'm going to turn the aircon off. So keeping on track, because there's nothing I like more than to not keep on track. I'm consistently not keeping on track, which is funny. A bit ironic. Anyway, so we have 1/4 as a power. I want to get rid of that. I don't like that there. I want to deal with these exponents. So that is going to be my next step in solving this equation, is to get rid of all the exponents. And we have two ones that are separate. So it's going to be a little bit challenging, but hopefully we can make it through it. Okay, so that is, that's representing 1/4. It's one portion of 4, where 4 is equal to 1. So to get rid of that exponent, I want to multiply it through by 4. I'm going to multiply it through by its inverse, essentially. And because you can cross these out, but I will show you that you multiply across 4, that just equals 1. But instead of just like solving that, you just cross them out. Yeah. And that's the easy side. So create another bracket. All raised to the power 4, boom. But you also have to raise this side to the power 4. And that comes along with another rule. So we'll do it over here. Let's do it in green, I guess, or keep it consistent. Do it in red. So when you have an exponent raised to another exponent, you're just going to multiply those exponents across. In this case, we have, I'll leave that there for reference. No, I won't. -1/2 times 4. Again, multiplicative fractions are very nice because they just multiply across. You will get -4/2 equals -2. So that is going to give you k to the -2. But also, before I forget, that 4 is going to distribute to both of those terms within that. So you also have q to the 4th. I don't know why that happens. Q to the 4th. Alrighty. So we had two exponents in the last step, and now we have another two exponents, but they are all on the same side. Next step is not to deal with those exponents first, but you will more divide these terms that are being multiplied by k. And that is because you are isolating k. This k. This has an exponent. I'm going to deal with that in a bit. I am just going to isolate k first. Now you may be thinking, why did you do that? You are giving me a fraction with exponentials on the top, variables, and it's a bit of a mess. But that's okay. You can deal with that. It's not too tricky. The most important thing is to get k by itself. -2 and this next step is going to be to move that -2 down to the bottom. And this is kind of why you're dividing through first to isolate K, because it gives you a nice rule of thumb over on the right hand side where you get, I'll explain it over here, I've explained it already, but it's good to just kind of drill the rules into you because there are so many and some of them look the same and it's easy to get mixed up. Example is that exponent raised to an exponent equals the exponents being multiplied. But if you have an exponent multiplied through by another exponent, you're going to add the exponents. I believe they have to be of the same base. Anyway, that is not what I wanted to tell you. What I wanted to tell you is that when you have negative of A and you bring that down, that becomes a positive exponent, which implies you will have q to the fourth over 1 over 2 times r over w to k to the second power. Now, why is that good? That is good because when you want to get rid of k on this side, you can just multiply this through by k2. Because 1 over 2 times 2, multiplying undoes the fraction. So in this case, when you multiply through by k2, I'll do it in red so you can see what we're doing in this step. Those are gone. And I know we've just moved k over to the other side. Am I going to deal with that again? That's okay. Oh God, this rule here foreshadowed what is coming up. Because then you have k squared 2k equals q4 1 over 2 r over w, and that is it. And now, applying this rule, they are of the same bases. A base means the coefficient, and this is k. You'll have, that's raised to the power 1, 2, so you'll have k2 plus 1 is 3. We'll give you k3. And you don't have to do that to the other side because this rule is only regarding multiplying these terms together. You multiplied this side by k over 2 and this side by k over 2. On the right hand side, it was cancelling out the denominator of a fraction. Not the full denominator, just a term in the denominator. And now we're going to deal with what that equality does to the left-hand side, which is the k to the third power. This isn't scripted, by the way. I'm kind of just going through this. which is why it seems so shoddy. R over W. Okay, we still have two exponents. What in the world are we going to do? Well, I'll skip ahead because I won't leave you in suspense. That Q4 is not going to go away. Well, it will change, but it won't go away. The reason is because we're going to take a third root. So I actually write the 3. That was terrible. And do that to both sides. That's got a 3 there. Now is equivalent to write it in exponential form, because why not add another exponent? Is equal to 1/3. Cube root is equal to the 1/3 exponent. So that implies, because a lot of people just cross these out, which they do, but that implies x 1/3 times 3/1. And you times that through equals 1. That is why they cancel. You are just left with whatever you had on that the power was raising it to. God, I should script these. Okay. So, you will get K. Okay, we finally got K by itself, which is good, because you could leave it like this. But usually we want to simplify things down as much as possible. I'm going to skip a line, blasphemy. Oh God. Okay, we're going to leave that cube root there. Going to leave our fraction here for now, but we're going to deal with the 1/2 times R over W. That is a multiplicative fraction. So that will equal R over 2W. And Q4, now it gets a little bit complicated because you're going to have that is what this represents, sorry. Equal K equals cube root. And I'm just going to swap these around because they're multiplicative. I'm not going to multiply them through. I am going to leave them like that. And lastly, I'm going to turn this root 3 into an exponent. So you will end up having K equals Q to the 4th to 1/3 okay, so you'll equal you'll end up with a exponent raised to another exponent. Like before, that is just multiplying them across. This is also raised to the 1/3. When you solve and you have to take a square root, or any root, sorry, not a square root, just this is a cubed root, it's good to put it back in terms of what the original equation was, which was all in terms of exponents. Because technically in the beginning, k to the 1/2 is just the square root of k, just in exponential. So q4 to the 1/3 is multiplied through, and like you can put that over 1, multiply them across, that will give you q to the 4/3. So k, like q to the 4/3, and then to w, solve some room. To the 1/3. And that is the answer to your question. Now, it would be totally okay to express this as that, as well as that too. So they're all the same expression. I've just put this back into terms of what the original equation was. So to finish off, I'll rewrite the original equation. And that is what we have done. Anyway, that's 24 minutes. That's a very long. Usually these don't take that long to solve. But trying to explain everything and doing it just without a script and very apparently thoughtful speech, because I take a pause every 10 minutes. Anyway, there we go.